30. We have a couple of batteries. The EMF one is 10 volts and the other is half of that, so 5 volts. And the resistances are all 4 ohms. What's the current in resistor 2 and resistor 3? So, with all Kirchhoff circuits, I'm going to guess the current. And I think in R1, the current's going to be going to the right. I'll define that as I1. And in R2, I think the current's going to be going towards the left. Again, this is just because of the EMF the battery's trying to drive the current around in the direction indicated. And then through R3, I'm going to guess the current's going to go downward. But instead of defining that as a new current, I'm going to use the junction rule and simply say that current going downward is the sum of the current flowing into the junction up at the top. And again, just a quick reminder, why is that going to be true? Well, the current from this junction and the current from this junction are going to join and head down here. So the current through this resistor, I1 plus I2, and at this point, it'll split back up again. Once I have that, I can actually write the loop equation for this first loop. Again, remember the voltage drop across each resistor must equal the EMF in that loop. In this case, I'm going through all the resistors in the correct order. So for this resistor up here, 4 ohms times I1 is the voltage drop across it. And then for the voltage drop across this one, again, it's 4 ohms. The current, though, now is the sum of these two, I1 plus I2. And the EMF in this loop is 10 volts. We can simplify that down a little bit. Simply write it as 8I1 plus 4I2 is equal to 10. For loop 2, I'm going to work around counterclockwise. Again, same kind of thing. First of all, for this 4 ohm resistor up here, the voltage drop is going to be 4I2 plus the voltage drop across R3, which is going to be 4 times I1 plus I2, just like up above here, equals the source of EMF in the circuit, which is 5 volts. Simplifying that down a little bit, we get that. Using the simultaneous equation solver on your TI Inspire or any other website you might happen to have, or just working out manually, you'll discover that the currents, interestingly enough, I1 is 1.21 amps, whereas I2, ironically, is 0. And you might say, wait a second, how is that even possible? Well, if you work at the voltage drops here real quick, let's assign this 0 volts, you'll actually discover something interesting. Because these two resistors are equal, we're at 10 volts here. I'm going to define this end over here as 0 volts. Because we have essentially the same current, because I2 is 0, what's going to happen? The voltage at this point is going to be 5 volts. We're going to lose half of it. And by this point down to 0 volts. Because of that, there is no voltage difference across this resistor on top here. There is no current going through it. And so, yeah, believe it or not, we end up with that. And so finally, what's the current in resistor 2? Well, since I2 is 0, it's just 0. And what's the current for resistance 3? Well, technically it's I1 plus I2 being 0. So it's just the current, or I1. Hopefully that makes some sense. It's an interesting result, which is kind of fun. Good luck.